Alright guys, welcome back. Today we're going to take a look at section 3.9, word problems. Okay, so not all these are going to be systems, some of these are going to be different types of word problems. A lot of this is going to be ACT review, so I know that seems like a long way away, but the closer we get to that day in April, the more we're going to be looking at problems like our opener. A lot of geometry problems on the ACT, so it's good to remember these facts, which I'm sure we learned last year. Okay, so let's take a look here. Part 1, solve for x. Find the measures of angles A and C. So as we can see from the picture here, right, we have a right triangle, ABC, okay, right angle at B, and I'm sure we remember that a right angle is a 90-degree angle. Angle A is x minus 10 degrees. Angle C is going to be 2x plus 10 degrees. And now if we recall, right, the three angles of a triangle add up to 180 degrees. So if I add these three up, so let's see, this is going to be x minus 10 plus the 2x plus 10 plus the 90-degree right angle should equal a total of 180 degrees. And now, right, let me go ahead and subtract this 90 over to the other side, and I can see that my two angles add up to just 90 degrees. And now I got rid of the parentheses, right, because there was nothing to distribute, so I don't need them. Now I can just go ahead and start combining some like terms here, right? X and 2x combined to 3x. Negative 10 plus 10 is 0. Those cancel out. So I get just 3x equals 90. Divide both sides by 3. And x equals 30. Done? Right? Done. I can move on. Problem here is good. Right? Right? No. Absolutely not. Answer the question. Find the measures of angles A and C. So angle A right there is x minus 10. So the measure of angle A is going to be 30 minus 10 is going to be 20 degrees. And now you can probably make an educated guess for angle C without doing it, but let's still write this out. Right? The measure of angle C is going to be 2 times 30 plus 10, which is going to be 70 degrees for my final answer. Okay? Alright, nicely done. Let's go ahead and move on here. So let's take a look at our warm-up. Now, this type of problem here is going to be one that we have to solve with the system. So let's go ahead and take a look. Fremont High School sells 780 tickets to the varsity football game. That seems like an important piece of information. So I'm going to go ahead and circle it. Adult tickets are $5. That seems like that's going to be important, right? Adult tickets are $5. And student tickets are $3. So $3 for student tickets. And the total revenue, so how much money we brought in from the show, or from the game here, is $3,140. So I'm going to circle that here. And now I'm going to circle this in red as well, because all three of these are talking about money. Okay, so I have a feeling I'm going to make an equation out of these three pieces of information. And the last thing here, determine how many adults and how many students went to the game. So, part A, label adults and students as either X or Y. So I'm going to go adults as X and students as Y. Okay, so part B, write an equation in terms of X and Y that equals the total number of tickets sold. Okay, well, if I look back up here, right, we sold 780 total tickets, okay, and so that's a mixture of adults and students, right, and so that means that X plus Y has to add up to 780. Part C, write an equation in terms of x and y that equals the total revenue from the game. Now, things that are nice here, right, is that it tells us that this is going to equal the total revenue. So this is going to equal the $3,140 from above in the problem. Okay? And now, here's where the price of the tickets comes into play, right? $5 per adult, so that's $5 for every adult, and $3 for every student, right? And now I'm going to take the money from each of those ticket costs, right, and I would add them together. Okay, and so here's my two equations. X plus y equals 780, 5x plus 3y equals 3140. And by this point, right, I'm sure we are all comfortable with solving with either substitution or elimination. So really, it's up to your best judgment as to what method we should choose. Personally, I think substitution is going to be nice here because in this first equation, in part B, x plus y equals 780, right? I can easily solve that for, let's say, x to be 780 minus y. And now I can take this value for x, substitute it into the revenue equation. So let's see, this is going to be 5. Now instead of writing x, right, I will write 780 minus y plus 3y equals 3140. Multiply, multiply, and so let's see, 5 times 780. Ooh, that's a big number. I think that's going to be 3,900 minus 5y plus 3y equals 3140. Negative 5y plus 3y, that's going to be negative 2y. If I subtract the 3,900 over, okay, actually I'm going to move over to the right here. Let's try this again. Alright, subtract the 3,900 over, I will get negative 2y equals, and now 3140 minus 3,900, a little bit of mental math, I believe that's going to be negative 760. So, divide both sides by negative 2, and y equals 380. So here's my answer for y, 380. And now I can take this value of y, plug it into what I solved x to be, right? X equaled 780 minus y, so I will write 380. And so x is going to be 400. And so I am done, right? Moving on. Right? Don't forget to answer the question. Right? Determine how many adults and how many students went to the game. X and Y are fantastic. We did a great job. Those are not my answers. Okay? Let's look back at my labels. Adults was X, students was Y. So final answer, do the same thing, right? Adults is X, so 400 students. Whoops, adults was X, and so I wrote students because I'm an idiot. 400 adults and 380 students attended this game. And so this is my final answer. Let's put a nice ugly star right next to it. Okay. All right. Good. Alright, good job. Let's go ahead and flip over to the next page here. Okay. And part 3 here, we have word problems, but different types of word problems. These aren't going to be necessarily with systems. They're just going to be general word problems, maybe with geometry, maybe with a little bit of algebra. We don't know yet. Okay. But let's take a look at example 1. A rectangular screen measures 27 inches by 36 inches. So, rectangular, right? So I will draw a rectangle. Oh boy. And this is going to go about as well as you'd expect. There you go. That's a nice rectangle. 27 inches by 36. Good. Find the diagonal distance between opposing corners. So diagonal, right? Let me go ahead and draw a diagonal in here. Okay. And so find the diagonal distance. So I'm going to call this x, right? This is what I'm looking for. And now this type of problem should actually look a little bit familiar. Okay, well at least the picture should, right? So if I highlight the diagonal and two of my sides in red here, right? And if I remember that at every rectangle there are 4 right angles, right? I actually see that I have a nice right triangle here. So kind of similar to our opener, right? We're dealing with another right triangle. And so we've actually seen this property before as well, right? Talking about sides of a right triangle, I can use the Pythagorean theorem. A squared plus b squared equals c squared, where a squared plus b squared are our two sides. So in this case, 27 and 36, the legs of the right triangle. So this is going to be 27 squared plus 36 squared equals my hypotenuse, which is the c side, and in our case is going to be x squared. Okay, so let's see. 27 squared is going to be 729. 36 squared is going to be 1296, and that equals x squared. And so now if I add these two together, this is going to be 2025 equals x squared. And so now this is something equals x squared, and so to get rid of a square, I take the square root of both sides. And so the square root of 2025 actually works out to be positive 45. And now some of you who are astute might go, but hey, isn't it also negative 45? Well, technically it is, right? Because negative 45 squared will also get you 2025. However, in this case, we're looking for a distance, right? Find the diagonal distance between opposing corners. And so I can't have a negative distance, right? So in this case, x is just 45. So my final answer, as always, is not x equals 45. I'm measuring in inches. So the diagonal here is 45 inches. This is kind of like how they measure television screens or computer monitors, right? They don't measure the length or the width. They always give you those measurements by the diagonal. Okay, so think of this as a 45-inch TV. Okay. So again, as you're seeing, right, 2 to 3 problems we've done. Nice little geometry review, right? Properties of triangles, right triangles. These are important things to remember as we move forward. Okay, and last but not least, we are not doing example 2 because that's not a fun problem. Okay, so good job today, gang. Sorry I can't be there, and I will see you mañana.